Okay, so back to Dr. Benton trying to figure out how far out into the ocean he can see on a clear day, assuming we don't have clouds or fog or something. What I've drawn here is the Earth over here in green, and we've got Dr. Benton standing out there, and I've put him on top just for convenience. And the idea is Dr. Benton wants to see how far he can see before his eyesight runs out on that circle, on that sphere, right? On the Earth's surface. And then we can look up, you can Google on the internet, that the diameter of the Earth's surface is about 7,926 miles. What we want to know is X, how far can Dr. Benton see? And I will tell you, you know what, for sake of ease, we'll make Dr. Benton about 6 feet. Those last couple inches aren't going to matter in the scheme of things anyway. All right, so what we have here, friends, is a secant line, including Dr. Benton's height, and a tangent line, right? It's this whole thing is the secant. So if I do secant tangent, I'm talking about the part outside the circle, the tangent line squared, which is his line of sight from his eyeball to the place where he can no longer see on the horizon. And then the part outside the circle would be the 6 for the secant. And on the inside would be 6 plus. Now let's be consistent. This is feet, this is miles. So we're going to come over here to our side work. 7,926 times 5,280 is 5,280 feet in a mile. And we get 41,849,280 feet for that diameter of the Earth's surface diameter of the sphere that is Earth. So this is basically, this green circle that I've drawn is basically a great circle, right? And so according to the order of operations, I'm going to add these two parts together first. I'm going to add 6 to that, and then I'll multiply by 6. And so I'm getting x squared comes out to be 251095716. And now we're going to take the square root of both sides. So that number square rooted in my calculator comes out to be 15846. Now keep in mind, this is how many feet Dr. Benton can see out into the ocean. So if he were to divide by 5 tomatoes, 5280, 5,280 feet per mile, to convert that to miles, he could see about 3 miles. It's 3.00. So about 3 miles is how far out you could see, in theory, on a clear day without obstruction. So kind of fun that that's a real life application of one of these theorems.